Water is an interesting substance with a chemical makeup that gives it some unique physical properties. A water molecule has an oxygen atom with two hydrogen atoms connected to it by covalent bonds. The V shape that the molecule makes is caused by the way that the oxygen atom's valence electrons repel one another. These covalent bonds are made up of a pair of electrons and are the key to many of water's unusual properties. Oxygen is more electronegative than hydrogen. This means that its positive nucleus pulls harder on the negative electrons in the covalent bonds than the hydrogen's nucleus. As a result, the oxygen atom develops a partial negative charge, which leaves the hydrogens with a partial positive charge. These partial charges create a positive end and a negative end to the molecule, making it what chemists call polar. The opposite charges of these polar molecules are attracted to each other, causing them to loosely stick together. The attractions between the water molecules are called hydrogen bonds. These hydrogen bonds give water a boiling point that is about 200 degrees higher than it should be when compared to other similar substances. The result is that water is a liquid at room temperature, but other similar molecules like hydrogen sulfide, hydrogen selenide, and hydrogen telluride are all gases. The polar nature of water molecules is also the reason that some substances dissolve in water while others don't. Take salt and oil, for example. Salt is made up of charged particles called ions. In this case, we have positive sodium ions and negative chloride ions. In solid salt, the ions are attracted to one another. The partial charges on the water molecules cause them to be attracted to the ions. When the ions are completely surrounded by the water molecules, the salt dissolves. Unlike salt, oil is predominantly nonpolar. This means that it doesn't carry any charges, so there's nothing to attract the polar water molecules to it. This is why water and oil do not mix. So, water's high boiling point and the way it interacts with different substances comes down to the polar nature of water molecules. Water's properties are all great examples of what we observe on the macroscopic level being influenced by what goes on at the molecular level and how we link the properties of chemical substances to those structures. Thanks for watching, and make sure to check out the other videos in this series here.